Hello and welcome. In this video, we are going to run a quick test just to confirm our detections that we created in the previous video. Okay, so to start, in Parrot OS here, you notice I don't have a shell open. We actually don't need the return shell to function. We just need the code to execute on the host. So I'm not too worried about that. So in your testing, you don't actually have to have the exploits always work as long as the code executes on the boxes that you're testing on. Okay. And looking back, we're in our Elastic instance here, and we can see we're in our alerts tab and nothing is generated in the past minute, which makes sense. Okay, so let's now go into our Windows box here. And we can close out of all this testing from our previous video. So we have this testing bat file here. If we execute it, it'll run all the fun stuff that we've created in this section. And let's get this going. All right, all the code should have executed there. We should have 3 alerts trigger. All right, and you may be asking why did 3 alerts trigger when we created 4? The answer is because when we work through the obfuscation section of our bat file here, we can see we're actually grabbing the text file and creating a bat out of it versus the bat file in transit. So we're actually not going to trigger this alert through how we made this bat file. Okay, but what we can do, if we were curious, let's say we edit this to say shell.bat, save it, and run this again. If you notice there was an error there, what we have to do, we previously moved the bat file so it no longer exists. So now we can just copy the file. We have both files existing. All right. And now we could run this and grab the shell.bat. And there we go. If we go into the folder here, we can see our shell exists. All right. And what we should see is a bunch of alerts now in Elastic. Once it triggers in about 5 minutes or so, we should see a handful of alerts from running this bat file 3 times. So we should see 3 individual alerts for that activity. And we should only see 1 for that network related alert. Okay. In which we're looking for that bat file in transit through the zeek.http data source. Okay. So what we could do is just go back to our alert section here, and we can keep refreshing it. We can see our 1 alert triggered here. So we can see the bat file. That just happened to trigger first out of the chain of events that need to occur. And what we can do is pop open this Manage tab, go into Rules, and we can see when these were last run. I'm going to have to let this bake for a couple of minutes here, but I will fast forward the video once the alerts have populated and we can talk about it. Hello and welcome back. You can see the output of all our testing. Okay. And if you notice, we don't have as many alerts as you might initially think, and that's because of our suppression rules. Okay. So we're suppressing based off the host. So we could have triggered that executable 100 times on the same host within a 5-minute period, and it would have still only triggered 1 alert, which is what we intended. Okay. So looking at our activity here, we can see our 4 alerts trigger. And this is exactly what we want to see. So we can walk through them. We can see everything being displayed, how we set it up. And we can see the relevant pieces of log data that gives the response team something to start looking into. All right. And we can see our 1 suppressed alert. Going to our next one, we can see the invoke web request downloading a bat file. And in the process args, you can see the exact file location and the name of the file. This is really helpful for the response team because that lets them know where to go look for that bat file in case they want to investigate what the contents is. Okay, so let's say we only have this, but we don't have the execution of that bat file. In that scenario, the bat file was never executed. Maybe there's a timer. Maybe it only runs once a day or runs on startup. Okay. In that scenario, the response team could potentially find that bat file, grab it, investigate, see what's in it, make sure it's not malicious, and get rid of it before it has time to execute. Okay. we can see 2 suppressed alerts, which makes sense based off of how many times we clicked on that bat file. Okay, so we clicked it 3 times and we have 1 alert here and 2 suppressed. So the math checks out. All right, going to our next alert here, we have PowerShell execution via a bat file. And we can see all the information in here, and we can see the exact PowerShell and the process args. All right. And again, 2 suppressed alerts. And our last one, we have the MSF PowerShell payload observed. Okay, this one's a little tricky to look at because we don't have a dump of the information. And this is an interesting example where sometimes Elastic doesn't give you everything you need right out of the gate. Okay, so in this scenario, we want to go about this a couple of ways. We can add an investigation note with some more detail. We could put something in the name to tell them more where to go. So for example, we can say potential MSF PowerShell payload observed in message field. Okay. And that lets them know, like, okay, I need to see the message field. How do I do that? So Elastic in the overview only gives you the highlighted fields. And there's a couple different ways to view all the fields. You can go into the table. And let's say we want to type in message. Okay. If we hover over this message here with this 3 dots here, we can see the whole message field here. It's a little awkward to look at. Okay. You could also copy to clipboard and view it there. Or you can go into the JSON and you can control F for something like $A, which is part of the query. And then we can see all the data in here. Okay. And typically I like going right to the raw log itself. So this table, while helpful, doesn't always do what you want it to do, but the JSON is just JSON. Okay. It's easy to query. You just control F, or you can just copy and paste the JSON off to somewhere else and manipulate it that way. Okay. And what's fun, as a little bonus content here, we have 2 alerts on malicious behavior, suspicious PowerShell execution here. Okay. And this is a critical with the risk score of 99. Okay. So whatever's triggering this is pretty certain that this is bad. All right. If we look into it, we can click this here to go look at the rule. And let's check this out. So this is endpoint security. All right. So what is happening is we have Elastic Defend integrated into the Elastic Agent, and that is on our Windows box. But if you remember at the beginning of installing our agent, what we did was turn Elastic Defend into detect only mode. All right. So this creates a detection, but doesn't really do anything with it. If we switched Elastic Defend and endpoint security from detect only to block, it most likely would have actually blocked the return shell from executing at all. Okay. So that's pretty typical of EDR products where things that are out of the box, like MSF Venom, Metasploit, things of that nature without any kind of obfuscation or attempting to be tricky in how it's operating and executing, it will often block it. Okay. But in our example, we're doing things pretty basic here. We disabled security. We have everything as detect only. Okay. We allow script execution, all kind of fun stuff you really would never want to do in a real environment, but works great for our test environment and this course. Okay. So this is just a good example of Elastic detecting this activity out of the box without really any configuration. All right. What's interesting to note here, we have 3 detections that we created versus the 1 that Elastic found. Elastic really only found that final piece of the puzzle. Okay. And if we scroll through the JSON here, we can see that it's detecting that MSF payload. Okay, so Elastic, for all intents and purposes, didn't care about the bat files getting downloaded or anything like that. And one last thing, as we scroll down in here, what we can do is look at this Analyze Event button for any one of these. Okay, so let's look at the potential MSF PowerShell payload observed really quick in this analyzer. If we zoom out here, we can actually see a pretty large chain of events that Elastic is correlating out of the box, which is really neat. So if we go to cmd.exe, we can see that testing.bat executing. It's executing PowerShell, and it's running these commands. Okay, so we can see it grabbing the file and executing the file for the return shell. Okay. Next up, we see the execution of that bat file, which was spawned by the PowerShell. That bat file is now executing our interpreter payload. Okay. And then finally, that interpreter payload is getting executed through cmd.exe. All right. So a really interesting, powerful way to view how this is all working. You can even see timing between each of these hops. Okay, so this is a great tool if we weren't the ones creating this activity, generating and executing it. Okay, we already have an in-depth knowledge of how this is working. But if you're coming in fresh and you only see this final hop here, it's really powerful to be able to look back and see exactly the chain of events that led to the activity that spawned the investigation. Okay. All right, this concludes our attack scenario 2, where we set up a more complicated example to walk through the detection creation process. Okay, in the next section, we're going to do something similar, but a little bit more advanced in the kind of activity that we're looking at. Okay, so similar to how attack scenario 1 was a little bit basic, and then in this section, we have something a little bit more advanced. We're going to make another hop similar to that in the next section. All right, I hope this has been helpful. Thanks for watching. I'll see you in the next section.